this guy. Okay, so here's the flow of our roadmap. Okay, so we prepare for and set limits of the assessment. How many machines are we looking at? What machines are we looking at? Let's document them with the machine inventory list. Okay, what is the span of life of this machine that we're assessing for? Are we assessing for production? Are we assessing for shipment, assembly, right? How much of a lifespan, or that tear down, breakdown, disposal? Usually it's just production, right? But let's set the limits of our assessment. Okay, so once we have a list and the limits of our assessment, now we can go into the meat and potatoes, is identifying tasks and hazards on that piece of equipment. Okay, so we're going through and we're looking at every single task that an operator or a maintenance person does, and then we're evaluating, is there any risk associated with that task? Little cheat code, look for things that move, right? Look for things that are hot. Things that move are usually good candidates for things that can hurt, right? Sharp things, pinch points, nip rolls. If you're having troubles, I'll touch on it in a different slide, but there's an appendice in the risk assessment standard, and it gives you some like starting points of things to look for. Sometimes it's easier if you see something, you're like, oh yeah, that is there. So that helps. But we're going to identify all the tasks and all the hazards. And when we do this at Omron, we come into a plant. We do this initially in our minds. We strip all of the safety stuff off the piece of equipment. Okay, so like that work cell there's got light curtains. We just pretend they don't exist because we want a base level risk score. Okay, we're not going to assume that stuff is safe. We'll verify that later in the process. We'll talk about that. Okay, so we get our initial risk based on a risk scoring system. Then we're going to go to this hazard control hierarchy. This is how do we mitigate against that risk. Okay, we apply that. Then we assess, okay, what's the residual risk after we've applied that? We're going to score that. And then is that acceptable? If yes, move forward. There's a step missing here before validate. Is residual risk is acceptable? Yes. Install and wire the equipment, then validate. If it's not, nope, then we're going to go back up and we're going to do it again. Okay. Okay, once we get to an acceptable risk point, we install, we can validate our solutions. There's validation documentation that we can provide examples of. You now have a documented risk assessment, an installed safety system, and it's been validated to show that all the safety systems are functioning as they should. There's also a verification piece. I'll touch on that. Okay. So prepare for and set the limits of the assessment. Well, I sure walked through a lot of this in that last slide. Okay, we talk about the team. So E&S managers, operators, maintenance personnel, engineers, electricians, production managers, specialists. Determine the scope of the assessment, right? So this is, yep, talked about that. Okay, where do I start? I get this question sometimes, like, hey, we want you to come out and do a risk assessment on our facility. It's like, no, promise you don't want us to do that. Okay, let's narrow things down a little bit. You guys probably have, most companies have an idea of the machine that kind of scares them a little bit. Good place to start, right? You're chuckling. Yeah, I was at a plant that makes arrows, and there was a piece of equipment there. We got in the room, and the one dude sat at the end of the table. He goes, I don't even like walking by that machine. Right, so that's a good place to start. It's like, yeah, he doesn't even want to walk. Like, let's start there. Okay, so only assess machines in the initially, right, that have the potential of amputation or fatality. Assess the operation and maintenance portion of the machine life cycle. Okay, don't worry about tear down, disposal. Okay, we got to start somewhere. Identify and assess hazards only or all tasks and hazards. Provide and review safe work procedures, control schematics, planned and unforeseen uses of the equipment. Okay, this is right out of that appendix that I talked about when you're looking for your different hazards. And by the way, there's tasks, and then there's hazards associated with tasks, right? But then there's just hazards that might exist, that there's no task associated. So keep an eye out for just hazards also. that's a possibility. And in those cases, you don't have to document. There's no task, but it's something dangerous, which I've seen before. Forgive me, I'm not thinking of a specific example, but just document the hazard and then do the risk analysis on that. Okay, so you're going to document all tasks associated, all foreseeable use and misuse of the equipment. This one is always contentious, right? It's like, well, the guy jumped 10 feet to, you know what I mean? Like he was, and I don't know, you know, it's like, why would he do that? You know, it's like, if you have a foreseeable misuse, account for it, but like, don't go too far down the rabbit hole, right? There's things that are foreseeable, over speeding the machine, foreseeable, right? Maybe, reaching in during production to do adjustments, foreseeable, okay? But, I always get questions on that one. It's like, yeah, people do some silly things and we can't be accountable for all of them, but let's try and at least figure out what they might do with the piece of equipment and we're good. Okay, any conditional hazards that could exist, different operating temperatures, things of that nature, right? Overspeeding, things like how will the machine change over its life cycle? Okay, stop time measurements. Think about how that machine ages in the field. Okay, and yeah, and that appendix will give you a list. Okay, this is right out of ISO 13849. I really like this because it's super simple. So like, keep it simple. How do I find a performance level requirement? This is a way to do it. Okay. Have you guys heard that word, performance level requirement? Yep. Okay. No. Okay. So for the folks that haven't, a performance level requirement is basically a measure of how safe do we make the circuit, but how far do we have to go to protect against this hazard, both with equipment and with the way that we wire it. That's the performance level. How does it need to perform? So when we do a risk assessment, the goal is to identify what that is, what that performance level is for each one of those hazards before we design the solution. And then we're going to design a solution and we're going to verify that it meets that performance level. Does that kind of make sense? Okay. Everybody's crystal clear on that one. Okay, so this is a very easy way to very simple way to get to our performance level required. Okay, so what we have here is our three factors: severity of injury, frequency and exposure to the hazard, possibility of avoiding or limiting harm. And then we're just gonna go through this flow chart, right? So for severity of injury, is it S1 or S2? Okay, slight, which is normally reversible. Okay, or is it serious? I would say emergency room trips are serious, right? Everybody agree? Yep. I would say slight is like breakout. We got a first aid kit here. We got some band-aids. We got some gauze. Probably slight. That's kind of how I look at that, right? But I like this because it's like, it's just, you know, it's easy to do. Frequency and or exposure to the hazard. Seldom to less often, or the exposure time is short, is F1. F2 is frequent to continuous. Okay, so what do you think, guys? 3 times an hour, guys got to access this area that has this hazard. F1 or F2? F1, F2s, okay. 3 times an hour, I was thinking F2. But it could also depend if it's a very short amount of exposure time, could be F1.
Just 13849 call out. Like we build equipment, so we do risk assessments all the time.
Cool.
But like we have definitions of slight versus serious. Like this is it's good because it gets you going where you need to go.
Yeah, it's vague. It's super vague. Yeah, totally. This is directly out of 13849. They don't break it out anymore. No. So if you could use this as the basis of your scoring system, and that's what we do. But we do the same. Like we break it out more so that it's not as cut and dried per se.
Sure.
I'll show you what our numbering system looks like. Good question. And then the possibility of avoiding or limiting the harm is if the hazard's there, I'm exposed to it. Can I get away and not get hurt? Or is it gonna happen? Am I gonna get injured? Okay, so P1, P2. So we go through this chart, right? We say, okay, this is a serious incident that would happen, right? It would be a serious injury. Let's say I am able to, I'm only interfacing it with it seldom, like once a week, okay? What's the probability of avoidance? And it's gonna happen, okay? Performance level D. So that's the PLR, performance level required of your safety circuit is a performance level D. By the way, cheat code, robotic systems, stuff like this that we see here, almost inevitable performance level D. Okay, most of them, I'd say like 85% are performance level D. Okay, the rest, well, a big swath of them are performance level D. Performance level E is a little more rare, but the majority of things that we assess are D. Okay, and we'll talk in the second half, like what that actually means when you design the equipment and how you wire it and what instruments you pick. This is our scoring sheet, so this is like where we break it out a little bit differently. So we assign a score of 1 through 10 for the severity. For the frequency, we do 1 to 4. And for the probability, we do 1 to 6. So our scale goes 10 plus 4 plus, so that's what, 20? So we have our max is 20. So the way ours works is from 0 to 6. We use all three of these factors, right? We score it, and if it's 6 or less, it's low risk, which is basically just like single channel safety. If it is 7 to 11, we categorize it as a medium risk, which is single channel safety circuit with some monitoring to make sure that there's no failures. And if it's 12 or above, we call it high risk. And then that would be 2-channel redundant monitoring control circuit. Okay, that's there. So single channel with monitoring, control reliable. And if this single channel with monitoring, control reliable, I don't even know what that means. We'll talk about what this is referring to is how those light curtains are actually wired into the control system, how that all functions. Okay. Just know that this up here requires it's redundant, right? More complicated wiring, but it's also guarding against the more severe hazard. So you see things that are less hazardous and they're less expensive on our recommendations. So there's less going on, right? We're only wiring a single channel device versus something that's more dangerous. We've got a lot more intensive equipment, more wiring, etc. Okay, so for my standards, folks, ANSI talks in, so the ANSI B11.0 talks in terms of this single channel with monitoring, control reliability. They talk in terms of single channel with monitoring and control reliable. That's how ANSI does it. The ISO standard is, they talk about performance level. Okay. And what I want you to know is that the performance level is the same as it's the same. It's describing the same features that the ANSI one is, but it takes it a little step forward with respect to things like it also factors in mean time to failure of the equipment, okay? And it takes into consideration common cause fault and diagnostic coverage. So it adds a couple of layers on top of the ANSI standard, okay? Because the Europeans like people more than we do. Gotcha.